Okay, here's another example. This one is going to involve uniform motion. Remember, for these uniform motion types of problems, distance equals rate times time. Everybody loves a good uniform motion problem, right? Well, here we go. Number 64, a fishing boat travels along the east coast of the United States and encounters the Gulf Stream current. Woo! It travels 44 miles north with the current in 2 hours. Then it travels 56 miles back south against the current in 4 hours. Find the speed of the current and what would be the speed of the boat in still water. So we're looking for the rates. We want to find the rate of the current and the rate of the boat. Okay? Let's say that we're going to let, we could say like R sub C, that could be the rate of the current. Okay? I'll just do that. Rate of the current. And then we could let R sub B be the rate of the boat in still water. Okay? Now, let's use this first bit of information. It travels a distance of 44 miles with the current. Okay? Now, if you're going with the current, okay, then the total rate is going to be the rate of the current added to the rate of the boat. Right? Because it's pushing you, and so you're adding those together. That is going to be that total rate traveled. Okay? Now, in this case, with the current, we go a distance, and remember here, y'all, distance is equal to rate times time. So it goes a distance of 44 miles at a rate of R sub C plus R sub B, and it takes that 2 hours of time. Distance is equal to rate times time. That's one of our equations. Okay? Now, if it goes against the current, okay, what the rate is in that case against the current is you're going to have the rate of the boat, and working against that or subtracting that out of there is going to be the rate of the current. Okay, does that make sense? Now it says, well, we're going to travel, in this case, it's going to go 56 miles. Okay, so again, distance equals rate times time. So on this one, it goes 56 miles, and the rate is whatever the rate of the boat is minus the rate of the current, because it's acting against that, going against the current, and it takes a time of 4 hours to do that. So there's, again, distance equals rate times time. All right, so here we're talking about the same rate of the boat, the same rate of the current in these two situations. So we are going to form a system of equations in these two unknowns. Okay? If I take the 2 through and clean this up a little bit, I'll have 2 times the rate of the, okay, because this one's going to be written first here, rate of the boat. Let me write 2R sub B first, then the 2R sub C second. That's going to be the same thing. Okay, that's going to be equal to 44. Now on this one, when I run the 4 through, that's the reason I wanted to write rate of the boat first. Okay, I'm going to have the equation 4 times the rate of the boat minus 4 times the rate of the current equals 56. Now, I really do think that what we probably should have done before we even started this, it would have made life a lot easier now that I'm looking at it. We should have probably just divided both sides by 2, okay? We'll still get that. When we go ahead and divide everything through by 2, we'll have rate of the boat plus rate of the current equals 22. Okay, there we go. That's a lot easier. Hey, and 56 is divisible by 4 here. What color do I want to use? Purple maybe? Okay, so if I divide both sides by 4, okay, I'm going to have rate of the boat minus rate of the current equals 56 divided by 4 is 14. Okay, so, that's another way to go. I really didn't need to form this system of equations here. Okay, I need this one. That's going to be nice because y'all, hope you realize right here, rate of the current minus rate of the current falls out, and we can just go do our addition method here. We're going to have 2 of those rate of the boat terms is equal to 22 plus 14 is 36. So the rate of the boat in still water is 18. Okay. Now, to get rate of the current, let me just go right back up here to this equation. That equation says that the rate of the boat plus the rate of the current is 22. We found the rate of the boat is 18 plus the rate of the current will be 22. So the rate of the current is going to be 4. And these are miles per hour, right? Everything was in miles an hour. So the rate of the boat is 18 miles per hour in still water. And the rate of the current is 4 miles per hour. Okay? So the total rate, okay, when it was going with the current, okay, it was the 4 plus the 18. It was a 22 miles per hour total, okay, and rate of 22 miles per hour times the time of 2 hours gives us the distance, 44. And then right up here, the rate when it was going against the current was 18 minus 4, so it was 14 miles per hour. If you take that rate times the time of 4 hours, you get the distance traveled going against the current. Does that make sense? Okay, that's a way to check it. But our answer ultimately is 18 miles per hour is the boat in still water. That's that rate. And 4 miles per hour is the rate of the current in the, was it called the Gulf Stream? I think it was the Gulf Stream current. So